Okay, quick review. I've showed you how to create measurements so that you can find length and width, height, distance between elements. I've showed you how to find area, volume, mass, and center of gravity. So I'll say okay to this and we will hide our measurements, inertia, and these measurements, again, this is not something you can modify or edit. It's telling you what the true size and shape of this part is. Okay? It's just a measurement feature. It's commonly used in a non-production environment where they're just trying to make something and they would need some quick dimensions on a part so they can go try and build it. Whereas model-based definition under the annotation tab are dimensions done in the 3D environment, which is different from a drawing because that's a 2D environment and they're drawn on a 2D plane inside a border. With the model-based definition, we have no borders. Okay, so again, this is called the model-based definition when you're doing your 3D tolerancing and annotation, building these dimensions in space, which was supposed to replace drawings, but I've heard in multiple companies now you have to do both, which just seems like a way to have more human error involved. Hopefully you're watching my techniques on how to do this so you reduce the amount of human error involved. I'm going to go ahead and hide the measurements. Whoops. And I'm going to go ahead and hide the annotation. And the sketch environment is an environment where you have constraints that are editable constraints. I can double click on any one of these values and change them. So it feels like we're doing it 100 times because we're doing it in multiple places for multiple reasons. We're going to go ahead and exit the sketch. When you're releasing the part, the final picture, we have to save in the engineering mode. And what you have to do is hide the absolute axis, hide the geometrical set, which should now be named construction geometry due to a previous video you've watched. Hide that. Okay, this should be your name here, and this top here should be whatever the name of the part's given in Canvas. And I'll be checking for that as well. But under the View tab, of course, I'm trying to prep this and I don't see it. Oh, there it is. Under the View tab, we have views. You can store the view. So what you do is you hit ISO View, Fit All In. Okay, so if it's off here in no man's land, ISO View, Fit All In will put this in the screen where it belongs. This is a view that's commonly saved for anywhere in production so that they know they can return to this view. So as the designer, what you'll do is use the camera to take a picture of this. So I click on this. All you have to do is click on this. It acts like a shutter and snaps the picture right there. And it calls it camera 1. I'm going to rename this. The proper name is capital letters ENG ISO -view. Enter. And it's now called Engineering ISO View 1. I click on it and it'll take you there. So why is that there? I'm a new user or I'm a guy in the shop. I've got this all cattywampus. I've lost a part. They're going to know that you can go to the camera and go back to that Engineering ISO view and it'll bring them back to the starting position. Okay, now don't hit Engineering ISO view again or it will take a new picture of it. So don't get it all cockeyed and then take a new picture. Just leave it where it's at and we'll go to our checklist. So the final part of this checklist, I'm going to be checking to see if everything is 4 places. The specification tree is in the correct order. Well, if you've been doing this the whole way with me, I know it's in the correct order. For this particular example, there's nothing in the construction geometry, which is called the geometrical set. For this particular example, there should be only one sketch and only one pad. If I see sketch 2, sketch 3, and it's not underneath the pad, there's 2 different sketches, then you got something wrong. If I see 3 or 4 pads, you got something wrong. I should have only 1 sketch and 1 pad. I should see the measurements, and they should all be in the hide environment. Same with the measure inertia. It should be in the hide environment, and the annotation should be in the hide environment. And then I should have a material applied. So your tree should look just like this. When you did the measurements, I just can double check that these are all 4 places. Okay. So in the measure command, when you have the pop-up window, I'm looking for 4 places in the measure command. In the checklist, I just talked about that no extra sketches or features. So 2 pads would be an extra feature, 2 sketches would be an extra sketch. I just put everything in hide. Everything has to be in hide with the exception of the actual solid itself. All construction geometry, all that other stuff goes into the hide environment. I just showed you how to create that engineering ISO view, and you would save it with the part body as the in-work object, meaning it has to be underlined. So you're going to right click on the part body and make it the in-work object to make sure when you're all said and done, this is how it's set. Save your model just like this, and then go make a picture that shows me you did that. I don't need a line 17. I'm going to get rid of add picture and then insert my picture. Okay, so that was for the last part here. 10 through 16 shows me this picture here. There's one more picture I got to add on this to finish this exercise off, and that's this one up here. I'll do that in the next video.